Okay, let's take a look at our notes, and we're going to be looking at our magnetic notes to begin with. So, what is magnetism? Well, there have been things called magnets forever, and they've known to have a property to attract tiny little pieces of metal. And we call this property of this attraction magnetism. And this has been around since ancient times for a very, very long time. So our bars have a north and a south pole on them. No matter which way they're shaped, they have a north and a south pole on them. And then the opposite, they are attracted to these. And then the magnets are also made of metal, and they are attracted to each other. So the magnetic poles, that's that north and south piece that we talked about. And the strength of the magnet is concentrated at those ends, so that's where you're going to get most of your attraction. And they are called the north and south poles of a magnet. And our Earth has a north and south pole, and we have a magnetic pole in our Earth, just like that. So that if you look at your compass and you're looking at north and south on a magnet, it should point to the north. The pole depends on the pole that it is seeking. Now, magnets can have two things. They can either have an attraction or a repulsion. And so magnetic forces, when like poles will repel each other, we call that a repulsion. So if I put two north poles together, they're going to pull apart. Unlike poles, your north and south, they attract. So the two properties of magnets is attraction and repulsion. They repulse with two opposite poles when you put north and south together, and they attract, they are attracted when you put a north and south pole together, and they are repulsed or repel each other when you put two of the same ends together. So again, I misspoke just a second ago. The unlike poles, the north and south, attract, and the like poles will repulse each other. Now, we're going to do an activity that involves magnetic field lines. And we can describe magnetic field lines by you take a tiny compass and you place it around nearby points of a magnet. And the direction of the magnetic field at any point is the same as it's directed by the compass. So if we would take iron field fillings and we drop it over top of a magnet, it's going to make lines that are very, very similar to this picture. And the lines are going to go in the same order as the lines here, as if I would put a magnet there. It would be going in the same direction. It would be northeast, northwest, southwest, etc. It's strong where lines are dense and thick, and weak where lines are sparse. So where you have a lot of lines that are closer together, then you've got the more strength. So here I have lots of lines that are much closer together, more strength. As I get towards the center of this diagram, they are farther apart, and therefore they are weak because they have less lines. See how much more lines I have along the north and the south pole. So the field lines go in a certain direction, and the unlike poles are going to repel them. So if I put unlike poles together, then if I would drop those iron fillings, they would go between the north and the south pole because they are attracted to each other. If I put two north poles together and drop those iron fillings, then the fillings are going to go away from each other. They're going to be repulsed by it. Okay? That is all we're going to talk about today, and that's the magnetic fields. We will later on start talking about electrical charges, forces, etc. At that time. We'll do that. All right, so that's all the notes for today.